Hi everyone, this is Deepak here. We are going to discuss about Project 2 for Data 620 for summer 2019. We are a team of five: Austin Chan, Justin Herman, Chester Poon, Deepak Mongia, and Michael Donald. This is Deepak here. So we are going to take this project to this project. Basically, we are asked to take a two-node network, which should be quite big, and um, the edges should only be between one set of nodes to the second set of nodes. There should be no same set edges, basically edges between two same set of nodes, two same nodes. So, so we have taken a network for NBA players wherein the data is taken from 2009 to 2018. There are multiple teams and multiple seasons, and all the players that played as a part of those seasons for various teams. And we are going to see how we can use our data to get some good insights. So we are basically trying to find a basically two couple questions and two important questions that we are trying to answer. We'll see how the data behaves and how data helps us to find those answers. So the first question is um, which players have been teammates or which are most important players, and then we are going to explore uh, who are the players who moved from one team to the other. So um, starting point, we are importing all the important packages that we need. Then we are reading the CSV file into a pandas data frame. So this is how our raw data frame looks like, the same as the CSV file that we just saw. And then we are basically renaming the columns, dropping the column that we don't need. So if you see here, we are having the first column as the team year combination. That means Blazers 2018. So the Blazers team of 2018 season, and the corresponding list of players for that season, the year, and the team name. So the team name here is Blazers. So we are just renaming it to the good name so that we can use them handy. Okay, moving on. So now we are grouping the number of players um, we are grouping by the team. So we see here that for Bobcats there are only 16 players in total in our data, which is justified because Bobcats and Hornets later, I mean, they are the same team actually. So moving forward, uh, with our data frame, we are creating a graph where between the team year combination and the player. So we are adding the edges based on the row. So here, this Blazer 2018 and Damian Lillard fall under one edge. They have one edge. Similarly for this and so on. So like this, we are creating the whole graph called G. And now we're just trying to see how our graph looks like. So we have drawn this graph, though it doesn't make much sense here, so we'll move forward. uh, Now we are seeing we have the number of nodes in our network is 827, number of edges is 2455, the total teams are 298, and number of players is 527. So these add up to form our total edges 827. So now we see it's a bipartite graph. So now we'll create the affiliation networks, or we will basically project graphs um, onto the teams and players and then use them one by one to see how they can help us find our information. So the first step we are using, we are projecting the graph on the players. So um, so basically we are trying to see which are the most important players, or which are the most connected players. So we have the weighted projected graph based on the players we are using, calling it player net, and then we are finding the degree centrality for the players. Top 10 come out to be these. So Anthony Tolliver is on the top, followed by Michael and Jared Bayless. Now we'll see how the closeness centrality is. So if you see here, Anthony Tolliver is having the top closeness centrality as well, just like he has the highest degree centrality. Okay, so moving on. Now we uh, move on to the betweenness centrality, and we find these to be the top 10 betweenness centrality players. Now we are implementing the island method for our players, and we are basically uh, trying to see how uh, what degree has what number of players. So we are creating this uh, small code wherein we found this important information about the degree and the number of players. So moving forward, uh, we're taking basically the players with degree less than 64 and degree greater than 64, and we are graphing we're plotting all these players. So we see Anthony, which had the maximum centrality, lies here on the graph. Now we are looking at the network of all current stars, and we find a good uh, graph here which says so the top degree centrality are these four members, these four players. Okay, moving forward, we are now going to explore the um, TeamNet networks. So we are going by the team. Um, Above, we created the TeamNet graph wherein we had projected um, the bipartite graph, the raw graph on the teams. So that means the number of edges, the edges that we have is based on the number of players that these teams shared. And please note here that we are going by the team and year combination as one team. Okay, so we just plot the graph raw and we don't find good information here, so we are going by the weights in our projected graph for teams, and we get this graph. So even though it's very, I mean, messy, we don't get much information, so we will explore further how the data looks like. So now we are trying to find the biggest weights between any two teams, and we find that the top teams which have shared the most of the players, they are all the same teams but but different seasons. So like Jazz in 2018 and 2017, they have 14 players. So 14 players who played for Jazz in 2017 also played for the same team in 2018 as well. So I mean, all in all, this doesn't really help us a lot, but it gives us a picture that uh, most of the players continued with their teams. So we'll move forward and see how the players, if there were any players which moved from one team to another over the seasons, and who were those players. So now moving forward, um, we are using the island method uh, to see um, what are the number of players, what are the number of teams that had weight greater than a certain value. So we are using iteration method here. We are going by iteration 6, and so basically if you see here the results, the number of weight is moving by 2 every time. So we'll go with the number of because we already saw that 10 to 11 weight range. We'll go with weight range 9 and try to analyze how the teams shared the members or the players which are 9 in number, greater than 9. So now we are basically trying to see uh, which all teams shared more than 9 members, and all of them are um, the same teams over the seasons again. So again, this um, we are simply plotting the same graph, g greater than 9, and it doesn't really give much clear picture how which all teams are connected because they are kind of overlapping. So so we just made an attempt to plot these graphs by taking the subgraphs and creating a dictionary out of it. So um, each part of the dictionary or each element of the dictionary is basically the the 13 or 14 subgraphs that were created out of greater than 9 island that we created above, and we are simply plotting them here. So as we see here, most of the teams that shared the 9 greater than 9 number of players are all the same teams over seasons. moving Moving forward, excuse me. So now we are trying to see how we are using the island method to um, to basically find the number of teams which had weight less than a particular value. Above we saw the weight greater than a particular value. Here we are going to use the island method in a slightly different way. Okay, now as we see here, we are basically checking if the data, if the e-data, the metadata of weight is less than that particular threshold. Only then we are using that in our new island subgraph. So, um, so now we are using, uh, we are calling this iteratively again, and we see that for anything less than 1, of course there would be nothing left, because that is why everything is 0 here. And then for um, any two teams having 3 or less than 3 players, it's 298, all basically all the teams. So it doesn't give much information again, because most of the teams, the lowest ones were all sharing 1 player, and they were all different teams, like Blazers 2018 shared with Nuggets 2014, and so on. So there are a good number of combinations which are 298 in number, so it doesn't give much information. So iterating further, we're basically using the island method to create a function to generate the number of teams lying between two weights. We'll use this function ahead, and so basically the first iteration for this function, we are trying to see how many teams shared the number of players between 5 to 8, and we saw that there were 174 such combinations, and there are 44 subgraphs. Okay, so now uh, we are creating another small code to see which all different teams shared 5 to 8 players, because it's a bigger number to analyze how the players which is in the range of 5 to 8 in number move from one team to the other. And if you see here, we are basically using just the team name from the team plus season name, and we are taking we're comparing the two teams. If the team name does not match, only then we are creating that new graph which will have the two different teams. So we see that we find only two combinations, which is Pelicans 2013 and Hornets 2012, and Pelicans 2014 and Hornets 2012. And if we see Pelicans and Hornets, it's basically the same team. So the number of players between 5 to 8, which the two teams which share that is basically the same team. So again, this this is not much good information as of now, but yes, we find that up to from 0 to 5, from 5 or above, there was no team which shared 5 or more number of players between each of them. So we'll try to zero in further, and next we are taking the islands between 2 and 4. We are using the same function that we created above, and we see that there were 288 such combinations which changed the team. Now this team here is team plus the year combination. So now again we're using a similar function or a similar way to see how which all two different teams moved 2 to 4 players in between them, like 2 to 4 players moved from one team to the other over seasons, and we find these many combinations, which is quite a big number, which is like 316 in count. I printed the we printed the number of such combinations in our loop. So again, this is really good information, but we'll have to break it up. So if you see, most of them fall under the sharing number of members being shared as 2. Uh, 2 and 3 would be a bigger number than 4. So we start with 2 first and see how many such combinations exist for 2. So now here we are using the same function to check between the range between 2 and 2, that means equal to 2. So we found 288 um, 288 such combinations wherein the team names are different. That means 2 players moved from team 1 to team 2, where team 1 and team 2 are completely different teams, and uh, over the seasons basically. But of course we have not considered the case like Hornets or Pelicans, wherein the team's name itself changed. Okay, so now we will just plot it the same graph for the teams which share 2 members or 2 players, and we got a good visualization here. Okay, so now similar to 2, we have taken the weight as 3, and here we found 23 different team combinations which had which had the players which are 3 number, which moved from team 1 to team 2. Okay, so now here we see which all teams did that. So here the edges basically are saying that the number of the players, 3 players moved from team 1 to team 2 and so on. So here Hornets, Bobcats, Pelicans, if there is any combination of these 3 teams, we are going to ignore them because they are basically the same teams. So here we find the same edges, the edges of the graph we found by three number of players sharing. Okay, moving forward, now we try to find the islands with 4. We use the same function, and if we go forward and we see how many different teams shared 5 players, and we find 5 combinations, and we're drawing them here, basically 5 edges here. If you see 1, 2, 3, 4 and 5, and Hornets basically here, this combination does not give any good information in the sense this is justified because they are basically the same teams, Hornets, Bobcats and Pelicans. So the good graph that we get, the good information that we get here is Bulls and Timberwolves. So now here we'll see um, we'll compare Bulls and Timberwolves because we see that the players moved from Bulls in 2013 to Timberwolves in 2018. Okay, so now um, we are basically creating a data frame out of our original data frame for Timberwolves 2018 and similarly for Bulls 11. And now we see that these four players played for Bulls in 2011 and they moved to Timberwolves in 2018. So it looks like these four guys are kind of good friends, probably. I'm not quite versed with NBA, so that's what um, we understand from this, because all these four players moved from Bulls. They were playing for Bulls at one time, and now they moved later on to Timberwolves in 2018. So similarly, we go to the other edge, Bulls 2013 and Timberwolves, and we find that these are the same four players who played for Bulls in 2013. So they continued playing for Bulls in 11 and then 13, and then they moved on to Timberwolves in 2018. Okay, so moving forward, uh, we are just trying to see the biggest, next biggest number, 5. Okay, so we are going to take the number of combinations of two different teams which had number of players moving from one team to another as 5, and we just found one combination, and this is like a null combination because these two are the same teams, just the names of the name of the team changed. So so the good information, the final information that we get from this analysis is that these are the four players which is the biggest movement from any one team to any other team over seasons, and it happened between Bulls and Timberwolves. So, uh, so coming to our conclusions, so like we saw in the players network, uh, the most connected player in the league is Anthony Tolliver that we saw based on the centrality values, and he was closely followed by Jeremy Lin and Michael Beasley. Then, of course, like the two all of the stars that have played with most All Stars were Kevin Durant and Russell Westbrook. From our teams analysis, we found that the biggest movement was four in number, and these were the four players who moved from Bulls to Timberwolves. And for the three weight combinations are the number of players three which moved from one team to the other were 23 in combinations. So we didn't go in detail if any of these teams were the same. So these are good findings that we found from the bigger network of NBA by dividing them or creating smaller islands out of the bigger network. So that concludes our project too. Thank you.